Hi guys, before I'll start with the explanation of the tasks which you can see on the screen, I want to say that this video is dedicated to all of my students and especially to all Emmas in all my classes. So Emmas, enjoy the video. And as you can see in the first task, and my students are quite familiar with these tasks because we were discussing them during our last lesson. So this is gonna be the whole solution for these two tasks. And the first task is about determining all quadratic functions whose graph passes through the points. And the second one is about sketching the graph of the function, which is basically the quadratic function, and then we will explain a kind of quadratic equation with the absolute value and with the parameter c. So I will explain these two tasks in this video. So let me just put this one a little bit more down so that I have enough space here. Now, if we want to find all the quadratic functions whose graph passes through the points, we are basically or mainly asked to find the equation of the function, which in the case of quadratic function is in general form defined as a times x squared plus b times x plus c, where a, b and c are the coefficients, and we are now supposed to find the values of these three coefficients, and once we will find them we know the equation of our quadratic function. So basically the next thing I want to say about these 3 points, you don't know anything about these points, you just know that they are somewhere in the xy plane, and you don't know anything about if any of them is the vertex or intercept with x-axis, though you can, if you have a look on these 3 points, you can simply say that this point is intercept with which axis? As x is equal 0, this means that this point is our intercept with the y-axis, because we already know that the intercept with y-axis has the first coordinate 0 and the second one is intercept with the y-axis or the coordinate which is on the y-axis. So based on this information you can simply say what is the value of any of these 3 coefficients, and if you are quite familiar you can read it directly from here that it means our coefficient c is equal to 1. And how can you find out easily? If you will put instead of x the 0, quadratic term and linear term will disappear, and it then means that the c value is equal to 1. So this is good news, because now our equation would look like as y equals a times x squared plus bx plus 1. So now we just have to find the values of the coefficients a and b. So let's do it. The second point, which is given here, we can basically say that this is one of our intercepts with the x-axis, and it is 1 and 0, but there is basically nothing special we can find or use from this point, I guess. And the last point is just any point of the parabola, which is the graph of the quadratic function, and its coordinates are 3 and 10. So based on these 2 points we can see, and if you are quite familiar with solving such an equations, you can see, and you should already know, that we will use the first point like px1, and it belongs to the function, so it means that 0 must be equal to a times, and as for this point x is 1, a times 1 plus b 1 squared, sorry, plus b times 1 plus 1. Okay, so in this equation we just know from the px, x and y values, and we will just replace these values instead of the unknown x and y. And as point a belongs to the function as well, it would mean that we will get the equation 10 is equal, because 10 is y in our equation, is equal to a times 3 squared, because x is equal to 3, plus b times 3 plus 1. So now we have like two equations with two unknowns, and this is something we can really solve very easily. So let me just get rid of these numbers like 1 squared and so on and so forth. So the first equation is 0 is equal to a plus b plus 1, and the second equation is like 10 is equal to 9a plus 3b plus 1. Okay, there are a couple of methods how you can solve this equation, and in this case I'm gonna use this one. From the first equation we can say that a is equal to negative b minus 1. Okay, and we will use this information, and we will replace a in this equation by the expression negative b minus 1. So basically we put this one into the second equation, and we will get the equation 10 is equal 9 times negative b minus 1 plus 3b plus 1. So as you can see, this is like quite good news, because now this is a simple linear equation with one unknown, which is in this case parameter b. So 10 is equal to negative 9b minus 9 plus 3b plus 1, which means 10 is equal to negative 3 plus 3 is negative 6b minus 8. So simple operation plus 8 means 18 is, 18 is equal to negative 6b, so multiplication by negative 1 over 6, which means b is equal to negative 3. Okay, so we have the value of the quotient coefficient b, which is negative 3, and if we want to find out what is the value of a, we just come back to this equation, and then it would mean a is equal to negative 3 minus 1, which is equal to 3 take away 1, which is equal to 2. So now we have all the information which is needed for finding out the equation of the quadratic function, so that it passes through the points which were given at the very beginning of our task. So the solution is, our function is given by the equation y equals 2x squared minus 3x plus 1. Okay, if you want to, you can check if it really works by using the favorite tool, which is called Desmos. And okay, I'm gonna do this now. So basically I will need to sketch the graph of the function. I'm sorry you cannot do this during I'm recording the video in this tool. So 2x squared, take away 3x plus 1. This is our graph of the function. I need to do this one. So here we go. Okay, let me do the print screen. Okay, and now I will put it on my screen. So basically you should be able to see the graph of the function. Okay, this is quite like, okay, I think this is okay. So as you can see, the point 0, 1 is on the graph, and it is here. This is our intercept with the y-axis. Now we have intercept with the x-axis 1 and 0. This is this point, okay, and the last point is with the coordinates 3 which is here, the line, and let me just sketch the line also here, and you can see that the intercept is really in a value of y being equal to 10. So this is all for the first task. Okay, now let's have a look and let's go to the second task, and let me get ready for this. I won't need this one anymore, not needed this one, so let me move this little bit more higher at the very beginning so I have enough space. Okay, in our second task, what is really tricky and something to learn about is the B part of the task. But before we go, it's really gonna be quite useful to solve the first one, which says sketch the graph of the function f, and the function f is given by this equation. So basically, to sketch the graph like really properly, there are a couple of information we need. So the first information is to find the coordinates of the vertex, then the intercept with the y-axis, and then the intercepts, if they exist, with the x-axis. So we are supposed to find out the values or the coordinates of these 4 points. Once we have them, we have quite a lot and quite enough points to sketch the graph of the function. So the easiest way is, in my opinion, to find the intercept with the y-axis, because we know x is then equal to 0. So if you find the function at x being 0, you can very easily find that 0 squared minus 0 is still 0. So the coordinates are like 0, 0. And when you see this information, you can very easily say that this is also one of the intercepts with the x-axis, because the intercepts with the x-axis, they both, if they exist, have the second coordinate equal to 0. So one of our intercept is 0, and how can we find the second one? It's really simple, because we already know that if y is equal to 0, then from this equation we will get the equation 0 is equal to x squared take away x, which is like really very simple quadratic equation, and this can be solved by factoring this expression here, quadratic expression, which can be written like x times x minus 1 is equal to 0, and we already know that the multiplication of any two numbers is equal to 0 if and only if at least one of these numbers is equal to 0. So in this case, x is equal to 0, or x minus 1 is equal to 0, which basically means x can be equal to 1. So these are the x coordinates of our intercepts, and as we already know, the first one is solved, and the second one will have the coordinates 1 and 0. Okay, now there is a formula how you can find the x coordinate of the vertex, which is negative b over 2a, but in this case I'm not gonna use this formula, because you don't have to remember this formula during my classes, and the easiest way now, without the formula, you can find the x coordinate, because you know that the x coordinate is really directly in the middle or in between these two numbers 0 and 1, which is in this case 1 over 2, or 0.5 if you want to, though you know I don't like decimal numbers very much. So we now know the x coordinate of the vertex, and to find the y coordinate, it basically means we have to calculate the value of the function at x being equal to 1 over 2, which basically means we have to calculate 1 over 2 squared minus 1 over 2, which basically means 1 over 4 take away 1 over 2. You find the common denominator, which is number 4. It means 1 take away 2, which is negative 1 over 4. So the y coordinate of the vertex is equal to negative 1 over 4. Now we have all the important information about the quadratic function, so we are now able to sketch the graph. Let me do it. So these are like x and y coordinates, very simple. So this is like, let me use the red color. This is the intercept with the y and the x-axis, one of them. The second one is here, which basically means that this is number 1 on the x-axis, and the coordinates of the vertex 1/2, which is somewhere here. And okay, as this is -1, so this is -1/2, so half of this is -1/4. So the vertex is directly here, and we know as a parameter is greater than 1, the parabola will be convex, or if you want to, it will open up. So it should look something like this. So this is the graph of the function defined by the equation y equals x squared take away x. We are done with the first part of the exercise. Now there comes the second one, and we are supposed to determine all real numbers for which the equation absolute value of x squared take away x and of absolute value is equal to c, so that it has exactly 0, 2, 3 or 4 solutions. Now let me just use the proper graph. So the function is x squared minus x, because it's quite like let's say important. So this is like x squared minus x in absolute value, and this is the graph of our function. So I will use really like nice picture here. Okay, let's use this one. Okay, so okay, let's do it. Now the thing is, before we start finding the solution, I'm pretty sure you already know that to solve this equation, this basically means that we are looking for like one function is equal to another function, which on the left side is the quadratic function with the absolute value, and on the right side it's the function which is a linear function, but in this case is like special function or subset of the functions of the linear functions, which is constant function. And you should realize that the graph of the gx function, which in this case is for example gx, can be defined as -2, or gx can be defined as 0. It can be very easily defined as gx is equal to 1, but you can also find this function like 5/2 or whatever, which basically means that these numbers are real numbers. So basically in this case my c is equal to -2, here my c is equal to 0, here c is equal to 1, and here c is equal to 5/2, which basically means, and this is our task, to find for which c's this equation here has 0, exactly 0, exactly 2, or exactly 3 or 4 solutions. So let's do it. There are like two ways how you can do it. It's like using the graph, which I'm gonna do, or the second one, you still can solve this by using algebraic approach, but I'm not gonna take this, I'm not gonna do this now. So we already know that this is the graph of the function, and we know how we found this function, because here you can see that this is the graph of the function without absolute value. So once you use the absolute value here, it means that this part of the parabola will be flipped over the x-axis, and then you will come to this final graph. And now what is important to realize, and I have explained a little bit a couple of seconds before, is that in this case, if we will have on the right side the equation the constant function, which in this case is y equal to, and now, okay, how much is it? It is 0.3, okay, and as you can see in this case our function, the red line, has no intercept with the black line, which is representing the graph of the function absolute value of x squared take away x. Now if you think about what's going on here, I'm changing the parameter c, so I'm increasing the parameter c from negative numbers, and I'll stop at 0, okay? So in this case our red function is defined by the equation y equals 0. So in this case our equation from the beginning of the task, x squared minus x is equal to 0, because c in this case is equal to 0. And as you can see graphically, how many intercepts do these two functions have? Yes, they have two intercepts, and these two intercepts are basically here and here. So the solution of this equation is x is equal to 0, and okay, this is the first root, and the second one is x is equal to 1. So in this case, if c is equal to 0, there are two solutions, and in our set of the roots are points or axes 0 and 1. Okay, now the question above is when the solution, sorry, let me use this. Let's find when the k, or the set of the roots, is empty set, which means there are no solutions or zero solutions. And if you understand the concept like really properly, this is if and only if c is from the interval negative infinity to 0 excluded. And I'll explain that one more time. So basically these are all the functions, like constant functions, which graphs are below the x-axis. So if I'll move this line below the x-axis, the red line will never intercept the black line, which is here, okay, and this line is representing our given function. So that's why for c from the interval negative infinity to 0, there is no solution for this equation. Okay, so how can we represent the equation? For example, x squared minus x is equal to negative 1, and we know, we are pretty sure when we read the graphs properly, then the set of roots is really equal to the empty set. Okay, now we basically understood when the function has two solutions, but this is not the only case when the function has two solutions. There is like many other cases when the equation has two solutions. And for example, let me show you, if we would have the function defined, or its graph being drawn here, okay, for example, let me use this one. Now you can very clearly see that we have like two intercepts, which are basically two solutions, which in this case are these 2 points. Okay, so these 2 points have their x coordinates, and these are the solutions for the equation x squared minus x is equal to 1 over 2, or if you want to 0.5. In this case, we know that the k has like two solutions. I don't know, and it's not the thing to calculate exact numbers here, but the main concept is to understand that if we will have such an equation, then we will have two solutions. So the conclusion is, if k consists of two solutions for the given function, and this is if and only if c is from 0 union interval. From which interval do you think? I should write now, it's gonna be open interval, and we can probably very easily see that it will go to the infinity. Okay, but the thing is, where does it start? And I'm pretty sure, and I hope you can see that this starts when the line is slightly above the vertex here. So basically we should read what are the coordinates of the vertex here, and we know that this is 1/4 from the previous graph, as you can see, because our vertex here without the absolute value has coordinates 1/2 and -1/4, so it was flipped over the x-axis. Let me just sketch it here very quickly. So basically here is our new vertex, and its coordinates are 1/2 and +1/4. Okay, so we can now very easily write, and we can understand that our equation has two solutions, exactly two solutions, if c is equal to 0. I have explained this a couple of minutes before, and now we know that the c must be from the interval 1/4 to the infinity. So if this is like the condition, let me just summarize here. So if c is from the interval from this interval or equal to 0, then the equation has exactly two solutions. If c is from the interval -infinity to 0, then our equation has 0 solutions. Now the next question was if we can find any c when the solution is like three numbers, so x1, x2 and x3, which basically means, this is if and only if, that our two functions have they have three intercepts. And when is it gonna happen? This is gonna happen exactly in one case, and this case is when c is equal to 1/4 exactly. So our equation has only or exactly three solutions if and only if c is equal to 1/4. Okay, and I'm pretty sure you can now find by your own when we will have four solutions. So our set of the roots will consist of x1, x2 or x3 or x4, and this is gonna happen if and only if c is from the interval. Yes, I'm pretty sure I could hear it here that you said it's gonna be for c being from the interval 0 to 1/4, which basically means, for example, if you would have the equation x² minus x in absolute value is equal to let's say 1/8. Okay, so I'm not sure if I'll sketch it very properly, but for example, let me sketch the graph of the constant function y equals 1/8, which is here more or less. So it means that this blue line has how many intercepts with the black line? Yes, these are four intercepts. First one, second one, third and fourth. And basically now it doesn't matter what are the exact values, because our goal was to solve or to find out all the c parameters, so that the equation x² minus x is equal to c has 0, 2, 3 or 4 solutions. If you think about the task, there is number 1 missing. Why is it so? Because this case doesn't exist for this equation. Okay, so the conclusion is that if c is from the interval, like here in the blue, If c is from the interval negative infinity to 0, then there is no solution. If the c is equal to 0 or from the interval 1/4 to the infinity, then there are two solutions exactly. And if c is equal exactly to 1/4, then there are 3 solutions. And the last case is that there are 4 solutions of this equation if and only if c is from the interval 0 to 1/4. Okay, I hope you enjoyed the video. I hope you have learned something new. I hope you understood the concept from our last lesson. And maybe now you can try the last exercise which was given during our last lesson. And the last exercise was, let me use this one. Okay, thank you for watching. If you would have any questions or suggestions for our next videos, just let me know. I would appreciate it. Bye bye.